Are you ready to learn the truth about forgotten survival skills that have been almost completely erased from the memory of modern humans? In an age when we've grown accustomed to relying on thermal underwear, gas burners, and satellite navigation, it seems inconceivable that anyone could not only survive, but truly thrive in conditions of total ice. This unique knowledge, honed over centuries, helped indigenous peoples, such as the Lakota and the Iroquois, survive the harshest winters on the Great Plains and in the dense eastern forests without a single modern technology at their disposal. We will explore the secret technologies of the past that seem like true magic today, how to survive in a windswept teepee, and what natural materials ancient hunters used to avoid turning into an ice statue overnight. This isn't just a historical excursion. It's a veritable encyclopedia of human resilience and engineering ingenuity, hidden deep within the mists of time. Be sure to watch this video all the way to the end, because in the finale, we'll reveal the main secret that baffles even experienced bushcraft experts. I'll show you a detailed, step-by-step breakdown of exactly how survival masters started a fire using the friction method in extreme sub-zero temperatures of -30 degrees, when wood becomes as hard as stone, and the slightest mistake means certain death. You won't find such an in-depth exploration of the topic on any other channel. Get ready. It's going to be cold, but very interesting. The hidden truth that everyone keeps quiet about is the human sense of smell's ability to locate sources of moisture deep beneath the ice. In winter, the streams of the Great Plains were covered by a thick crust, completely concealing this vital resource from the eyes of travelers. Locals learned to use the slightest changes in the composition of the cold air to search for hidden reservoirs. The snow cover acted as a natural filter, allowing specific vapors from unfrozen underground springs to rise to the surface. A person with the right training could detect this subtle mineral scent even through meter-high snowdrifts. The search process required complete concentration in a specific body position above the surface of the frozen ground. The person leading the way would kneel down and bring their face as close as possible to the white snow crust. In this position, the biting wind did not have time to disperse the damp odors emanating from the depths. Slow, deep breaths through the nose allowed for a precise analysis of the moisture level in the frosty air. The barely perceptible scent of wet stone and deep soil served as an absolutely reliable signal of the presence of water. This skill was based on understanding the difference between the smell of dry, frozen snow and wet ice. Dry snow has a neutral, almost pungent smell that stings the nasal passages when inhaled deeply. Vapors from flowing water make the air softer and heavier, even at sub-zero temperatures. Recognizing these subtle nuances required years of experience in harsh winter conditions. A mistake in choosing a spot for excavation meant a waste of a huge amount of precious energy. To test the chosen spot, they used long, straight sticks made of hardwood. They probed the depth of the snowdrift with them, assessing the snow's density before beginning the hard physical work. Compacted snow over flowing water often had a looser structure due to constant microscopic evaporation. If the stick sank into the snowpack too easily, this confirmed the correctness of the site chosen by scent. Only after this double check did people begin digging to access the coveted moisture. They had to dig with their hands, protected by thick leather gloves made of dense bison or deer hide. The top layer of snow was pushed aside, creating a wide funnel for easy access to the lower layers. As they dug deeper, the snow became denser, turning into a hard, icy crust. This crust was broken through with pointed stones or sturdy bone tools, specially prepared for such tasks. The work was carried out methodically and without haste to avoid excessive sweating in the bitter cold. Once the water had been collected, the hole punched in the ice was never left open to the freezing wind. The opening was tightly sealed with a large piece of clean snow, forming a reliable insulating plug. A layer of loose snow was piled on top of the plug to completely conceal any traces of interference with the natural landscape. This was done to ensure the spring did not freeze all the way to the bottom and could be used in the future. Such careful stewardship of resources ensured sustainable survival in the same territories. Navigating by the scent of water was not merely a technical technique, but a means of deep interaction with the environment. The sense of smell served as the most reliable compass in a world where all visual landmarks merged into an endless white expanse. This skill required absolute mental calm and the ability to shut out all extraneous thoughts during the search. Modern people, accustomed to running water, have completely lost the sensory sensitivity necessary to replicate this feat. The cost of such a loss is measured by the severing of our connection to the most subtle mechanisms of survival. I'd love to hear your perspective. What do you think about navigating by scent? Share your thoughts in the comments. Be sure to subscribe to the channel. A secret that has only recently been revealed lies in the unique ability to listen to frozen bodies of water. Air temperatures on the plains could drop so rapidly that visually estimating the thickness of the ice became impossible. Indigenous peoples determined the exact depth of a river's freeze-through solely by the pitch of the sound produced by the ice cover. To do this, they used heavy wooden clubs to strike the surface of the frozen water in a rhythmic pattern. By the nature of the sound reflected back, they could unerringly judge the safety of the crossing and the intensity of the approaching cold. The thin ice that formed at the beginning of winter produced a high-pitched, ringing, and prolonged sound when struck. This sound carried far down the valley, resonating in the empty space between the water and the ice crust. Walking on such a surface was extremely dangerous, as it could break under the weight of a person walking on it. Such a hollow resonance meant that the frosts had not yet reached their full strength, and a thaw was possible. People understood that to cross the river safely, they had to wait for lower temperatures. As the cold intensified, the structure of the frozen water changed, becoming denser and more solid. When blows from a club began to produce a dull, short, and low sound, this served as a sure sign of strength. The low-frequency sound indicated that the ice had frozen to a great depth and was firmly bonded to the banks. It was safe to move across such a surface in large groups, carrying heavy loads and materials for campsites. It was this very sound that signaled the onset of true, deep winter, which forgave no mistakes. Experienced trackers could distinguish the slightest changes in this icy acoustics as the weather shifted. If the dull sound was suddenly accompanied by a faint crackling from within the monolith, it warned of a sharp drop in temperature. The ice contracted from the extreme cold, creating internal stresses ready to tear the surface with deep cracks. To produce the correct sound, the mallet had to be made of very dense and dry wood. Soft or damp wood dampened the resonance, preventing an accurate assessment of the density of the frozen surface beneath their feet. The blow was struck strictly vertically, with equal force to ensure the consistency of acoustic measurements along the entire route. The person leading the group constantly tapped out the route, creating a safety soundtrack for the rest. This rhythmic tapping became an integral part of the winter soundscape of the Great Plains. Interestingly, different types of bodies of water had their own unique acoustic signatures as they froze over. Lakes with stagnant water sounded different from fast-flowing rivers due to the varying structure of the forming ice. Ice over fast-flowing water was often more porous and produced a higher-pitched sound even when quite thick. Indigenous peoples were well aware of these differences and made adjustments to their acoustic calculations. This deep understanding of the laws of physics was based on centuries-old traditions of continuous observation of nature. Understanding the sounds of the ice also helped in finding the best spots for winter ice fishing. Areas with specific acoustic characteristics indicated zones with slower currents or changes in the bottom relief. In such areas, drilling a hole was physically easier, and the chances of successfully replenishing supplies increased significantly. Acoustic analysis saved energy and time, which in winter were the most vital assets for survival. The ability to listen to nature replaced complex geological exploration tools. Today, this skill seems incredible and completely beyond the comprehension of people from urban cultures. The noise of megacities has permanently robbed people of the ability to distinguish the subtlest acoustic nuances of their surroundings. The ability to determine the strength of a material by its sound has remained only in highly specialized industrial sectors. Could modern devices replace such an absolute natural hearing in the extreme conditions of energy scarcity? In the next chapter, you will learn how the behavior of crows changed before the thaw. A secret passed down from generation to generation reveals methods for forecasting the weather without instruments. In winter, any changes in atmospheric pressure and temperature were critical for planning migrations and setting up camps. The indigenous peoples of the subarctic and the Great Plains closely observed the black silhouettes of crows against the gray sky. These large birds possessed an incredible sensitivity to pressure changes and air currents. Their flight became the most accurate barometer, warning of the imminent arrival of dangerous spring thaws. During periods of stable, bitter cold, the crows moved smoothly across the sky, using only infrequent wing beats. They flew low over the tops of the pine trees, conserving energy in the dense, cold air. This trajectory confirmed that weather conditions would remain unchanged for the next few days. People could calmly continue their work reinforcing shelters or gathering firewood from distant locations. The stable weather served as a guarantee that the ice crust would not give way beneath their feet during the long journey. However, before the arrival of warm cyclones, atmospheric pressure began to drop sharply long before temperatures rose. Air currents became unstable, forming invisible upward spirals of warm air above the icy expanses. The crows reacted instantly to these changes, switching from their usual horizontal flight to complex aerial maneuvers. They began circling at great heights, allowing the warm currents to lift them effortlessly. This behavior of the black silhouettes high in the sky was a sure sign of an approaching thaw. The temporary camp was set up on high ground to avoid flooding from suddenly melting snow. Twice the usual amount of firewood was gathered, as wet wood burned much less efficiently during a thaw. People checked the waterproofing of their shelters and leather clothing, preparing for heavy precipitation in the form of wet snow. All these preparatory actions began a day before one could physically feel the rise in temperature. Nature gave a warning, and ignoring this warning always came at too high a cost. This forecasting method required daily, continuous observation of the environment from the very early morning. Black dots against a white background were the only contrasting reference point by which one could read air currents. The observer had to be able to distinguish between ordinary foraging and specific flight in warm updrafts. This knowledge was passed down as a vital element of survival culture, on par with the ability to make fire. The connection between atmospheric pressure and the behavior of nature was studied thoroughly. Even today, meteorologists confirm the high accuracy of such bioindicators in predicting local weather anomalies. Birds' sensitivity to barometric pressure far exceeds the capabilities of many on-site electronic sensors. However, modern people have stopped looking to the sky for answers about tomorrow. The loss of this observational skill makes people completely dependent on satellite forecasts and digital technologies. Please like this video if you're amazed by such an accurate method of weather prediction without electronics. What was found in the old archives of the first colonists describes an incredible process of creating a flame. Starting a fire by friction is in itself an extremely difficult task, requiring enormous physical effort and skill. Doing this at a temperature of -30 degrees Fahrenheit was considered impossible for the European pioneers. The indigenous peoples possessed a unique technology for preparing materials, allowing them to strike a spark even in the most bitter cold. Success depended on a perfect understanding of the properties of wood and the strictest adherence to the temperature balance of the materials. The main problem in severe frost was the complete freezing of moisture inside any wood fibers. Even a branch that appeared dry contained microscopic ice crystals, which turned into water upon friction. This water instantly extinguished the heat generated, preventing the wood dust from heating up to its ignition temperature. To avoid this, the necessary components for kindling were always carried in direct contact with the human body. The warmth of the skin kept the wood dry, ready for use at any moment. The tool consisted of a support board, a sturdy rod, a bow made from a flexible branch, and a bowstring made of rawhide. The support board was made from soft woods such as poplar or cedar, capable of quickly producing charcoal dust. The rod was carved from harder wood so that it would not wear down faster than the support surface. Just before work began, these parts were taken out from under warm clothing and put to use immediately. Every second counted before the frosty air had a chance to cool the prepared tools. The process of kindling itself took place inside cupped palms, which shielded the tinder from the surrounding environment. As soon as the tinder began to smoke more intensely, it was placed into a pre-prepared pyramid of thin, dry twigs. These branches were gathered exclusively from the lower, dead tiers of coniferous trees, where they were protected from the snow. The flame flared up in a fraction of a second, providing vital warmth in the hopelessly cold expanse. This moment was considered sacred, as fire was the only boundary between life and death. The right to carry the fire-starting tools was entrusted only to the most experienced and resilient members of the group. The fate of the entire party during unexpected stops depended on their physical strength and reaction speed. A broken bowstring or lost tinder was tantamount to disaster, as there were no spare materials along the way. The leather for the bowstring had to be perfectly tanned so it wouldn't become brittle and snap in the cold. Every detail of this mechanism was checked dozens of times before a long winter trek. Modern attempts to replicate this feat in sub-zero temperatures most often end in failure. Without first warming the materials with body heat, friction leads only to the formation of useless cold ash. Synthetic clothing and gaslighters have completely supplanted the understanding of ancient heat transfer physics. The art of creating fire from a cold piece of wood has forever remained in the arsenals of the past. Is it possible to replicate this method today? In the next chapter, you'll learn how they coped with blinding snow. One of the most underestimated dangers of winter treks was the merciless reflection of sunlight off the endless white surface. On clear, frosty days, UV levels on the snowy plains reached critical levels, capable of burning the retina. Snow blindness set in imperceptibly. First came a slight stinging sensation, then the eyes began to water, and by evening, a person would lose their sight. Losing one's sight in a winter forest meant an inability to find shelter, start a fire, and, as a result, certain death. To protect their eyes, indigenous peoples developed ingeniously simple, yet absolutely reliable optical shields. The most common method involved geometric carving on wood or thick birch bark. A curved plate was carved from a piece of bark, precisely replicating the contours of the human face around the eye sockets. In the center of this plate, two narrow, perfectly straight horizontal slits, no more than a millimeter thick, were cut. These thin slits drastically limited the flow of light reaching the eye's sensitive retina. At the same time, the width of the slits provided a sufficient field of view for confident movement across rough terrain. The inner edges of the slits were always smoothed and coated with a thick layer of black wood ash. The black color absorbed any residual glare that might reflect off the inner edges of the bark directly into the pupil. This method of artificial darkening worked on the same principle as modern polarized sunglasses. The plate was secured at the back of the head with thin leather straps, ensuring a snug fit against the cheekbones and bridge of the nose. This snug fit prevented side glare from snowdrifts from entering under the mask. The manufacture of such goggles required high precision and the use of the sharpest bone knives. If the slit was too wide, ultraviolet light would penetrate inside, negating the entire protective function of the design. If the slit was uneven, it distorted perspective and made it difficult to accurately judge the distance to objects. Carvers spent hours perfectly smoothing the inner edges so as not to damage the eyelashes when blinking. Each such optical device was custom-made to fit the anatomical features of a specific person. In emergencies, when there was no time to carve the bark, a quicker protective method was used. The skin around the eyes, cheekbones, and bridge of the nose was thickly rubbed with a mixture of ground charcoal and animal fat. The black mask on the skin acted as an anti-glare coating, absorbing the sun's rays reflected off the snow. This technique is still used today by professional American football players to protect against stadium lighting. The fat prevented the charcoal from flaking off and additionally protected the delicate skin of the face from frostbite and strong winds. The use of charcoal also helped reduce strain on the eye muscles during hours of gazing into the distance. Without protection, a person would reflexively squint, leading to severe headaches and rapid fatigue on the journey. The dark mask allowed the eyes to stay wider open, preserving the clarity of peripheral vision, which was critical for detecting dangers. This simple physical barrier saved them from pain described as hot sand poured under the eyelids. Charcoal was always readily available wherever a fire had ever been lit. Wearing wooden goggles required some getting used to, as they significantly restricted vertical vision. To look down at one's feet, a person had to tilt their head forward sharply, altering their posture and body balance. However, this discomfort was a small price to pay for the ability to maintain clear vision until the end of a long journey. Archaeological excavations confirm that the design of snow goggles remained unchanged for millennia. The ideal shape, discovered through trial and error, required no improvements until the advent of tinted glass. This device is a striking example of how a deep understanding of the physics of light was realized using the simplest natural materials. Today, these artifacts are housed in museums, astonishing visitors with their functional simplicity and effectiveness. Eye protection was not a luxury, but a basic element of every hunter's winter gear. What large synthetic food manufacturers keep hidden has long been used in the winter forests of North America. During the deepest snows, when hunting yielded no results, the threat of starvation became a very real one. Indigenous peoples knew that massive coniferous trees could serve not only as building material for shelters, but also as a source of food. They learned to extract vital calories and carbohydrates from the cambium, the thin inner layer of pine and spruce bark. This process required a precise understanding of botany and strenuous physical labor in the cold. The cambium is a living, actively growing layer of the tree located between the hardwood and the rough outer bark. In winter, this layer concentrates the stored nutrients, sugars, and starch that the tree needs for spring growth. On the outside, this layer is securely protected by a thick shell of dead bark that cannot be chewed or digested. To reach the nutrient-rich layer, it was necessary to use special bone scrapers or sturdy wedges made of hardwood. Cambium was harvested only from trunks of a certain age and size to ensure the highest concentration of carbohydrates. The process began by stripping the trunk of its rough outer layer using heavy wooden hammers. The blows were struck carefully so that the outer bark peeled off in large chunks, exposing the light-colored and moist inner surface. Then, using a bone scraper, people began to cut long, thin strips of white or yellowish cambium. These strips resembled elastic ribbons, possessing a characteristic, strong coniferous aroma and a sweetish, astringent taste. From a single large tree, it was possible to gather enough material to sustain a small group for a day. The harvested cambium was rarely eaten raw due to its tough, fibrous structure, which was difficult to digest. The strips of bark were cut into small pieces and simmered for a long time in leather containers using hot stones. Prolonged heat treatment broke down the tough fibers, transforming the woody tissue into a thick, nutritious, and slimy mass. The resulting soup was rich in vitamin C, carbohydrates, and trace elements that prevented the development of scurvy and exhaustion. This thick broth had a bitter, resinous taste that saved thousands of lives during the harshest winters. In cases where it was impossible to build a fire and cook food, the harvested cambium was dried in the wind. The thin strips froze and became brittle, after which they were ground into a fine wood powder using flat stones. This flour could be stored for weeks and eaten dry or mixed with melted snow. Sometimes the wood flour was mixed with leftover animal fat, creating a high-calorie emergency ration for long treks. This preservation method allowed people to build up a food supply where, it would seem, there was nothing but snow and wood. Knowing which specific trees were safe to eat was critical for survival. Not all conifers were safe. Some contained toxic resins capable of causing severe poisoning and convulsions. Experienced people could unerringly identify the right pines by the color of the needles, the shape of the trunk, and the smell of the resin in the cold. The bark was harvested carefully. Only a narrow vertical strip was removed from each tree so that the plant would not die. This sustainable use of natural resources ensured that the forest would continue to feed people in future years of famine. Eating trees was a last resort for survival, resorted to only when supplies of dried meat were running low. It was an exhausting process, yielding minimal calories while requiring maximum physical energy for harvesting and processing. However, it was precisely this technique that saved many tribes during prolonged snowstorms that blocked all movement. The tree provided heat from the outside in the form of a fire, and heat from the inside in the form of high-calorie hot broth. Did modern survivalists know about this method? In the next chapter, you'll learn how they coped with this terrible weather. The temperature inside temporary winter shelters depended directly on the efficiency of distributing and retaining accumulated heat. Building a large fire inside an enclosed space made of animal skins or snow was deadly dangerous due to the risk of carbon monoxide poisoning. To ensure safe heating while sleeping, indigenous peoples used a method of heat accumulation with stones. The selection, heating, and proper use of heat-retaining boulders transformed the icy shelter into a safe and warm refuge for the entire night. This method required an understanding of the properties of various types of rock and a precise calculation of their cooling time. Only smooth, rounded stones collected from dry riverbeds long before the onset of deep snow were suitable for heating. The use of wet or porous stones was strictly prohibited, as the water inside them could boil and shatter the stone into dangerous fragments. Granite or basalt served as the ideal material, capable of withstanding high temperatures and releasing heat slowly and evenly. The selected boulders, about the size of a human head, were placed in a large fire built outside, several meters from the entrance to the shelter. The stones were heated in the fire for several hours until they began to radiate a powerful, almost palpable heat. When the stones reached their maximum temperature, they were carefully removed from the flames using long sticks made of green wood. After clearing the surface of ash and embers, the red-hot boulder was carefully rolled inside the prepared snow or leather dwelling. The stones were never placed directly on the floor. A special recess was prepared for them, lined with a layer of dry earth or green spruce branches. This layer prevented the snow floor from melting and protected the sleeping skins from accidental ignition in the dark. Inside the shelter, the stones began to act as powerful radiators, creating a steady and safe flow of dry heat. A single large, red-hot stone was enough to maintain a temperature above freezing in a small shelter for 6 hours. The air inside warmed up quickly, allowing people to remove their heavy, damp outer clothing and dry it before the next trek. The heat radiation from the stones was gentle and even. It produced no smoke and did not deplete oxygen in the enclosed space. People lay down to sleep with their feet toward the heat source, as frozen limbs posed the greatest danger during the night's rest. Proper positioning of the bodies around the stone ensured maximum comfort for every member of the group. Sometimes small, smooth, and moderately heated stones were used for individual spot heating during severe frosts. Such a stone was tightly wrapped in a thick piece of dry leather and placed under a blanket or in a fur sleeping bag. This improvised heater was placed on the abdomen or lower back, where the body's major blood vessels are concentrated. Circulating blood carried the heat from the stone to all the limbs, preventing frostbite during deep sleep. The leather wrapping provided reliable protection against burns and slowed the stone's cooling process until morning. The process of removing the cooled stones and replacing them with new ones required coordinated effort and kept the doors open for as little time as possible. In the morning, the completely cold boulders were rolled outside to be placed back in the fire for the following night or for cooking. This cyclical heat storage system allowed for the conservation of scarce winter firewood by utilizing the fire's energy with 100% efficiency. Firewood was used only to heat the heat transfer medium outside, which eliminated the risk of fire in the confined space of the dwelling. The physics of this process is identical to that of modern ceramic heaters, but it was used thousands of years ago. The ability to organize such heating was a critically important skill during prolonged stops caused by powerful snowstorms. A storm could last several days, making it impossible to leave the shelter, even to tend an outdoor fire. In such cases, several huge heated stones were dragged inside at once and buried in deep pits beneath the sleeping areas. The earth above the stones warmed up, creating a heated floor effect that lasted for several days of complete isolation. This engineering solution ensured the group's survival in conditions where the outside air temperature dropped below all conceivable limits. The impact of the Arctic wind on exposed skin was no less devastating than the cold itself. While moving across the open plain, the face and hands were constantly exposed to the wind, leading to painful micro cracks and deep frostbite. It was impossible to protect the face with thick masks because of the condensation from breathing, which instantly turned the fabric to ice. To create a reliable barrier against the icy wind, a thick protective ointment made from readily available natural ingredients was used. The formula for this ointment was based on the properties of animal fat and fine wood dust collected from cooled campfires. The base for the protective mixture was the internal fat of bison, bear, or deer, which solidifies with a high density. The fat was carefully rendered in leather containers using hot stones, purifying it of any protein, impurities, and meat fibers. The purified product could be stored for months without losing its properties or becoming rancid in the harsh winter climate. To the melted warm fat, they added the finest white ash from burnt birch or aspen, sifted through a cloth. The ash acted as an absorbent and thickener, transforming the liquid fat into a dense, viscous, and heat-resistant paste. This thick ointment was applied generously to the cheekbones, nose, chin, and exposed wrists before every outing in the cold. The layer of fat created a water-repellent film that completely blocked the evaporation of natural moisture from the skin's surface. Without evaporation, the cooling of the epidermis slowed significantly, allowing the body to retain heat in the peripheral blood vessels. The ash in the ointment made the film matte and denser, preventing it from melting away due to body heat. Additionally, the alkaline properties of the ash provided a mild antiseptic effect, protecting small cracks from inflammation. Applying the ointment was a mandatory morning ritual for every participant in a long trek across open terrain. The mixture was rubbed in using circular motions, gently massaging the skin to increase blood flow to the most vulnerable areas of the face. In the bitter cold, the applied layer froze instantly, turning into a second skin, elastic and completely impervious to the biting wind. A person wearing such a protective layer looked unusual due to the grayish tint of their face, but this mask was more reliable than any fabric. It did not restrict facial expressions or hinder breathing, which was extremely important during high physical exertion. In the evening, after setting up camp and building a fire, the protective layer had to be properly removed so the skin could rest. To do this, they used pieces of soft hide and warm water, gently washing away the grease accumulated during the day. If the old ointment was not washed off, it could clog the pores, disrupting the skin's natural thermoregulation and respiration. In the morning, the procedure of preparing and applying a fresh protective mask was repeated with absolute meticulousness. Discipline in skincare was an integral part of the culture of survival, where there was simply no room for trivialities. This method of protection was widely used by all peoples living in subarctic conditions and on open, windy plains. The effectiveness of the combination of fat and ash surpassed that of many modern cosmetic creams for frostbite. Modern creams often contain water, which crystallizes in severe cold, causing additional microtrauma to the skin. The ancient recipe completely excluded the presence of water, relying solely on the insulating properties of heavy lipids and carbon. This primitive biochemistry demonstrates a profound practical understanding of physiology and the properties of available natural materials. Without this protective layer, exposed skin in the wind at -30 degrees would freeze in a matter of minutes. Frostbite on the face not only caused severe pain, but could also lead to systemic cooling of the entire body through the capillaries. The ointment served as an invisible shield, taking the full brunt of the merciless elements during long treks. Caring for the physical condition of every group member ensured the group's overall mobility and chances of a successful return. Knowledge of these barriers was passed down by word of mouth as the most valuable legacy of their ancestors. When the weather suddenly worsened on the open plains, building a complex shelter out of wood became impossible due to a lack of materials. In such situations, the only available building block was the snow itself, covering the ground for miles around. Indigenous peoples perfected the art of creating quick snow shelters, known as survival trenches. These were not traditional Eskimo igloos made of blocks, but structures dug deep into the snowdrifts that required minimal time to build. A properly constructed trench protected the group from hurricane-force winds and retained body heat even without a fire. The choice of location for the trench was determined by the wind direction and the depth of the snowdrift. A deep snowdrift behind a natural barrier, such as a small hill or a large fallen tree, served as the ideal shelter. Using wide bone shovels or snowshoes, people would quickly begin digging a narrow trench in the deepest snow. The trench's width had to be just enough for a person to lie down at the bottom, pressing their shoulders tightly against the walls. The length was calculated based on the number of people in the group, who would lie down for the night in a single line, head to toe. The depth of the trench was a critically important parameter. It had to exceed the height of a seated person by at least half a meter. The excavated snow was carefully piled along the edges of the trench, forming solid parapets that further increased the overall height of the walls. The bottom was carefully leveled and packed down, after which it was lined with a thick layer of coniferous branches or spare leather hides. This insulating bedding was absolutely essential to prevent heat loss from direct contact between the body and the frozen ground. The ground and snow beneath the body drew away heat much faster than the frosty air above, The most difficult stage was creating a sturdy roof that could withstand the weight of freshly fallen snow and the force of a blizzard. Skis, snowshoes, spears, and any long poles available in the group's arsenal were laid tightly across the trench. Large pieces of thick leather or raincoats were stretched over this rigid frame, with the edges securely fastened using snow blocks. The final layer on the roof was loose snow, which quickly froze in the wind, creating a monolithic insulating dome. Only one small ventilation hole was left on the side, away from the prevailing wind to ensure a supply of oxygen. Inside such a narrow trench, the temperature stabilized around freezing solely due to the heat of human bodies. The air did not circulate, but was tightly contained within the enclosed space, creating a thermos effect in the icy desert. People huddled close together, minimizing their exposed surface area and conserving precious energy throughout the storm. In this semi-conscious state, the group could weather the storm for several days, carrying only supplies of dried meat and snow to quench their thirst. The inability to build a fire was offset by the ideal geometry of the space, which prevented heat from escaping. The main danger while in the snow trench was the gradual buildup of carbon dioxide from the breath of the tightly packed people. The ventilation hole had to be constantly cleared from the inside with a stick so that it wouldn't get blocked by the blizzard. If the air became too heavy, the person on duty would carefully lift the edge of the leather roof, letting in a breath of fresh, frosty air. This balance between retaining heat and ensuring ventilation required constant monitoring and absolute discipline from everyone taking shelter. Panic or unnecessary movements in the confined space could lead to the roof collapsing and the certain death of the entire group. For an experienced group, digging the trench took no more than an hour of coordinated, non-stop work until they were drenched in sweat. This speed was a decisive factor when visibility dropped to zero and the temperature plummeted to critically low levels in a matter of minutes. Snow, while the cause of the cold, simultaneously became the most reliable protector against its destructive effects thanks to its porous structure. The architecture of the survival trench is a masterpiece of minimalism, utilizing the laws of thermodynamics to preserve biological life in inhospitable conditions. Knowledge of these principles allowed people to travel vast distances without convoys of construction materials. Equipment failure during a winter crossing was a common occurrence, requiring immediate repair right out in the cold. Leather straps lost their elasticity in the extreme cold, becoming brittle and snapping under the load of sleds or snowshoes. It was impossible to use spare leather cords unless they had been warmed up beforehand, for which there was not always enough time. As an ideal and incredibly durable repair material, the indigenous peoples used frozen spruce or cedar roots. The process of harvesting and processing them in severe cold was a unique example of improvised forest engineering. The winter harvesting of roots began with a search for large trees felled by the wind, whose root systems had been torn from the ground. The snow was cleared away, exposing long, thin, and flexible roots growing close to the soil surface. These roots were cut down with axes or chipped off with sharp stones, trying to obtain pieces at least a meter long. The cut roots were as hard as stone due to the sap and moisture frozen inside them. It was absolutely impossible to use them in this form for binding parts. Special heat treatment was required. A bundle of frozen roots was brought to the fire and slowly warmed over a low flame or hot coals. The heating had to be very gentle. An open flame could scorch the wood, making it brittle and useless. As the internal moisture thawed, the root began to become pliable, exuding sticky hot resin onto the surface. This resin was quickly scraped off with the blunt edge of a knife, simultaneously removing a thin layer of the tough outer bark. The cleaned and heated root turned into an elastic, incredibly strong cord, ready for immediate use. Complex knots were woven from these hot spruce roots to fasten broken sled runners or cracked snowshoe frames. The unique property of this material lay in its behavior as it subsequently cooled in the frosty air. The flexible, hot root, tied in a tight knot, shrank significantly as it froze, clamping the wooden parts together tightly. The resulting joint was stronger than iron staples and did not dry out from constant mechanical stress during movement. This natural binding could last for months, withstanding the most extreme operating conditions on rough terrain. For finer work, such as mending clothing or tying off arrowheads, thick roots were split along the grain. The splitting was done with teeth and hands, dividing a single root into several long, thin, and flat strips. These strips possessed remarkable tensile strength and did not stretch when wet, unlike leather straps. Working with split roots required dexterity, as the material cooled quickly and became stiff again. Craftsmen managed to tie dozens of knots in the few minutes while the wood fiber retained its elasticity. This repair method allowed the group to keep moving without interruption due to technical breakdowns of transporter equipment. Knowledge of the properties of coniferous tree root systems turned any forest into a vast storehouse of durable fastening materials. The use of wood's natural shrinkage during freezing demonstrates a deep understanding of the laws of physics and biomechanics. The ability to find a way out of a hopeless situation using what lay literally at their feet was the foundation of the philosophy of survival. These technologies proved that nature provided all the necessary tools to those who knew how to use them correctly. We see that survival in harsh conditions was based not on fighting nature, but on a deep understanding of its laws and properties. Every technology, from sound navigation to extracting calories from wood, was the result of millennia of experience and absolute adaptation. This knowledge has enabled indigenous peoples to thrive in areas that modern people consider uninhabitable without infrastructure. What topics related to the lives of indigenous peoples would you like to see in future videos? Be sure to subscribe to the channel so you don't miss new episodes.